Hello! In the previous video, we established that the photon theory can qualitatively explain all the observations of photoelectric effect. But that's only qualitative. To fully accept a theory, we must have quantitative proof as well. So what can provide a quantitative proof? So according to photon theory, Ke max goes to hf minus the work function, right? So if the theory is really correct, then plotting Ke max against f should give us a straight line graph. If you don't see a straight line graph, we will reject the photon theory. So how did physicists obtain such a graph? That means they went back to their experimental setup, run the photoelectric experiment using lights of a certain frequency, then from the stopping potential, calculates the Ke max. So that's one data point. Then they switch to another light source with another frequency, which should give another Ke max. So you just have to find enough light sources of different frequencies so that you can get as many data points as possible. So it turns out the data points really line up along a straight line. So let's join them up with a best fit line. What do you think the gradients of this straight line graph should be? So you are plotting y is equals to mx plus c, right? So the gradient of this straight line graph should be the Planck's constant, 6.63 times 10 to the power of negative 34 joules second. Now what do you think is the meaning of the y-intercept? So this is the y-intercept, right? So that corresponds to the negative of the work function. What about the x-intercept? So this is the frequency at which Ke max is 0. That means this is the frequency at which the emitted photoelectrons have 0 Ke. So this must represent the threshold frequency. Or you can look at the equation. Remember the work function is equals to hf naught. F naught is the threshold frequency. So when f is equals to f naught, then the right hand side is 0, meaning Ke max is 0. Okay, now all these data points come from an experiment using the same emitter, right? So the emitter can be made from different metals. So for each metal, we can obtain a straight line graph. For example, maybe with sodium, you get this straight line graph. With zinc, you get another one. With platinum, you get another one. Now notice all of them are parallel lines. It has to be so because all of them have the same gradient of the Planck constant, right? All these lines have the same gradient. The only difference is their work function. So sodium has a work function of 2.3 electron volts, zinc 4.3 electron volts, and platinum 6.4 electron volt. Meaning for sodium, photoelectric effects can be observed even if you use visible light. But if zinc, you will need ultraviolet light. Because even violet light has a photon energy of around 3.1 electron volts only. So if you want to knock out electrons from zinc, you need ultraviolet light. And for platinum, you need ultraviolet light of very short wavelength. So when physicists obtain all this data, Albert Einstein was proven correct. Alright, that's all. Ta-ta!